before I start this video, I just want to preface that by dimensions, I don't mean like different worlds, or different, realities or things like that. I mean like one-dimensional, two-dimensional, three-dimensional, four-dimensional, in more like math terms, like spatial dimensions. Okay, so how can we view a fourth dimensional object? What does a fourth dimensional object look like? And what I imagine it to be, just from my very limited research and thought on the matter, is that a fourth dimensional object would appear as just like a dot, like a three-dimensional thing, like a very small three-dimensional thing, infinitely small, and then it'll slowly grow bigger. And then once it reaches its full size, it'll start shrinking down again, and then it gets smaller and smaller back to that like that small point, and then it disappears from our dimension. Now, why I think like that is because how I got that is because obviously we can't see the fourth dimension. Our brains aren't wired for comprehending what fourth dimensional properties are like. So what we have to do instead is work with the dimensions that we can comprehend. And that is 3D, 2D, and 1D, and I think zero dimensions is just like a dot. And then we can find, mainly we'll be working with 3D and 2D. And then by studying the relationships between these two dimensions, we can extrapolate that information and then apply it to 4D and 3D. Or we can try. Maybe this is all wrong. We don't know. So I can start by talking about 3D and 2D. So to answer our question from before, what would a fourth dimensional object look like going into a third dimension? We can try to answer that by examining how a third dimensional object looks like in a two-dimensional world. So let's first establish what I mean by 0 to fourth dimensions. Zero dimension, I think I talked about it before, I would consider just like a point, like a dot, but infinitely small. It has no dimensions, it's just a point, it's just there. And then a first dimension or 1D object would be like a line. So I have here a pencil. It is three-dimensional, but let's pretend it's one-dimensional. So we take that point and we extend it out. And so it's a line, and that's what one-dimensional. And then for a two-dimensional object, we take this line and we extend that out. We extend the line out, basically layering different, like a bunch of layers of the one-dimensional object outwards, so that it's like this notebook. Pretend it has no height, so that's obviously a two-dimensional object. It's like a shape. And then a three-dimensional object is if we take a notebook and then we stack a bunch of other notebooks on it, and then so with those layers it has a new dimension. So it just it has another part to it that makes it three-dimensional, and then it's like a Rubik's Cube. So a fourth dimension, how can we picture like a three-dimensional thing? Where does the line go? If it just protrudes out, isn't that still three-dimensional? So it's very difficult to picture that, and I'm sure there's a bunch of other theories talking about what fourth dimensional things, like how to make it, but I don't know. So back to being in a two-dimensional world and what a three-dimensional object would look like going into a two-dimensional world. Let's say this notebook is our world. Let's pretend that we are in a two-dimensional world, and so it's a line. Our entire world does not have height or anything like that to it. That's not a factor at all. And instead, we can only see how wide it is. So an object in a two-dimensional world would look one-dimensional. So let's say there was just an object like that size, but then there's an object that size. So these are the different properties of an object in a two-dimensional world. So if an object from the third dimension goes into our two-dimensional world, what would that look like? Well, let's take this kind of like rounded cube. If a third-dimensional object passes through our world, it'll start with the tip, right? It'll start with the very first contact, and that to the two-dimensional people will look like just a point, just an object that appeared out of nowhere, a very small object that just appeared out of nowhere into our world, and we have no idea what's going on, why is that there, that wasn't there before. Anyway, as the third-dimensional object continues to pass through, it gets larger and larger to our two-dimensional world. And once it reaches its maximum width, it starts shrinking as it continues passing through until it's just a point once more. And then after that, it completely disappears. So from that, we can sort of guess that a fourth-dimensional object, like I said in the beginning of this video, would start off very small, like a very small three-dimensional thing, and expand and then contract, and then boom, it's gone back into the fourth-dimensional world. Additionally, what we can guess about the fourth-dimensional world is that if we were in the fourth-dimensional world, we would be able to see 3D objects in a very different manner. In fact, I believe that we would be able to see a three-dimensional object, both its outside and its inside at the same time. So kind of like X-ray vision, but it's difficult to visualize what exactly it would look like since we can't think that way, but we would be able to see the outside and inside at the same time. And why I say this is because in a two-dimensional world, let's come back to our handy notebook. If I were to draw, I have here a Sharpie. If there were to be an object in the two-dimensional world, like a circle, a two-dimensional person in that two-dimensional world would just be able to see, okay, so for the outside of the circle, they would just be able to see the walls of the circle, right? They can't see inside. But if there were, say, like a square inside, they wouldn't be able to see the square. But in the third dimension, as we are, we can see above it. We add a different dimension. We can look at it from a different perspective and see both the inside and the outside at the same time. So we would be able to see there's a square inside. So maybe in the fourth dimension, we would be able to see a three-dimensional object both inside and outside. And there's a wonderful website called 4dtoys.com. Check it out. It's very cool. It shows this, what I'm talking about right now. If we had a kind of, if we were able to see the different slices of a fourth dimensional object through a three-dimensional lens, we can see the different properties of the object. So it would look like the object is changing, it looks different, but the surroundings, the 3D surroundings, will look exactly the same because it's in the same spot, except we're technically moving and seeing the different parts of the fourth dimensional object. So although we can't see all of the entire fourth dimensional object at the same time, we would be able to see its three-dimensional parts that pass through our world, pass through our dimension. And that ends my spiel about the fourth dimension and what objects there look like in comparison to the other dimensions. This video is probably just reiterating things on the internet that I've just looked into, so I don't know how helpful this is, but I just think it's a really cool way. It's a really cool thing to explore and to explain. at least from what I've interpreted of it. So I encourage anyone who's watching this video to go look into the fourth dimension and just investigate it for yourself and see what you think. Maybe you agree with me, maybe you disagree with me, and that would be amazing. So, bye.